Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are starting another part of triangles, class 10th. Let us start with Theorem 6.6. So far we are done with exercise 6.3. Now we have Theorem 6.6. Theorem 6.6. It says the ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. What does it mean? The ratio of the square of the sides is equal to the ratio of the areas of the similar triangles. See, let me take two similar triangles. Suppose this is one triangle. Similar to this triangle. Let us name this triangle as A, B, C. Let's name this triangle as X, Y, Z. These are two triangles which are similar to each other. Triangle ABC is similar to triangle XYZ. So what is given? Triangle ABC is similar to triangle XYZ. You got it? This is given. To prove, we are going to prove area of this triangle, the ratio of area of these triangles. That means area of ABC divided by area of XYZ. This is equal to the ratio of square of corresponding sides. That means AB by XY, because AB corresponds to XY, AC corresponds to XZ, and BC corresponds to YZ. So AB by XY whole square, or you can say, since we already know that if this triangle is similar to this triangle, then AB by XY is equal to BC by YZ is equal to AC by XZ. That's true. Why? Because the triangles are similar and sides must be in same proportion. So I can say AB by XY, but I know AB by XY is equal to BC by YZ because triangles are similar, and equal to AC by XZ, same reason. So I can say either this square or AC by XZ whole square, or I can say BC by YZ whole square. This is what we are required to prove. Let us do a bit construction. What I'll do in construction, draw perpendiculars just like this. AM and XN. So I'll write draw AM and XN perpendiculars to to BC and YZ respectively. You got it? AM and X. Drop AM and XN. Sorry. XN perpendiculars to BC and YZ respectively. Then let's prove this now. Let us start with the area of triangle. You know, since area of triangle is equal to 1 by 2 times base times corresponding altitude. You know this, which implies that then if I could find area of ABC, that is equal to 1 by 2 times, let us take base as BC, so 1 by 2 times BC times corresponding altitude for BC is AM. Let's have like this, and area of XYZ, this is equal to 1 by 2 times base YZ times corresponding altitude XN, just like this. Then if I could get the ratio, which implies that area of ABC divided by area of XYZ, that is equal to 1 by 2 times BC times AM divided by 1 by 2 times YZ times XN. You got this one? Then, which implies that area of ABC divided by area of XYZ, it is equal to 1 by 2, 1 by 2 goes, that is BC by YZ times AM by XN. Can I write like this? 1 by 2, 1 by 2 gets cancelled, BC by YZ times AM by XN. So far so good. So let us call this as equation first. Let us call this as first. Then let us compare this triangle and this triangle. Now consider triangle AMB and triangle X and Y. Let us have these two triangles. What we observe here, since I can say angle B is equal to angle Y, angle B is equal to angle Y. Why? Cast for triangle ABC is similar to XYZ. Since it's given that triangle ABC, whole ABC is equal to XYZ, then angle B is equal to angle Y, corresponding angles of similar triangles. So I can say cast for triangle ABC is similar to triangle XYZ. Then I have angle AMB is equal to angle X and Y, each 90 degree. Therefore, triangle AMB is similar to triangle X and Y by angle-angle similarity criteria. Got it? So AMB is similar to X and Y. Then I can say AB by XY, then AB by XY, AB by XY is equal to BM by YM. Or I can say AM by XN. Let's write AM by XN. Let's use these two sides. AB by XY is equal to AM by XN. Why? Corresponding parts of similar triangles. Sides are in proportion. And let us call this as second. Now what I get from first and second is from first and second we get what we got? Area of ABC divided by area of XYZ is equal to BC by YZ times AM by XN. Now replace AM by XN by AB by XY. Can I write that? You see again, area of ABC divided by area of XYZ is equal to BC by YZ times AM by XN. Instead of AM by XN, I am writing AB by XY because we proved that this is equal to this in second. So we have this. Got it? Which implies that then I can do one thing. Area of ABC divided by area of XYZ is equal to BC by YZ. Instead of BC by YZ, I'll write AB by XY. BC by YZ. Replace it with AB by XY. Why? I'll give you the reason. Then times this same AB by XY. As you know, triangles are similar. As triangle ABC is similar to triangle XYZ, implies ABC is similar to XYZ. That means all three sides are in proportion. Implies AB by XY is equal to AC by XZ is equal to BC by YZ. You got the reason? As triangle ABC is similar to triangle XYZ, that means all three sides, all corresponding sides are in proportion. So we have AB by XY is equal to BC by YZ. That's why I replaced this BC by YZ to AB by XY, because BC by YZ is equal to AB by XY. I wrote in place of BC by YZ AB by XY. Then keep this as such, AB by XY. Then what I'll get from this and this? Implies area of ABC divided by area of XYZ is equal to AB by XY whole square. Now I know AB by XY is equal to AC by XZ is equal to BC by YZ. So I can write area of this by this is equal to AB by XY whole square, or AC by XZ whole square, or BC by YZ whole square. Therefore, area of ABC divided by area of XYZ is equal to AB by XY whole square is equal to AC by XZ whole square is equal to BC by YZ whole square. So we are done. This is what we were required to prove, hence proved Dirac demonstrandum. Make a note.